Okay, we're on to lesson 2 for topic 4. We're going to talk about, still with triangles. Today we're going to talk about isosceles and equilateral triangles. So the first thing I kind of want you to do is think about an equilateral triangle and an isosceles triangle. What are some things that we know, or even some things that we may notice about these diagrams. And for an equilateral triangle and an isosceles triangle, something you need to remember is that the triangle sum for all triangles is always 180 degrees. So don't forget your 3 angles have to add to 180. Okay, so let's talk about equilateral. So equilateral gets its name because you have 3 equal sides. And if you have 3 equal sides, then you have 3 equal angles. And the word for that is equiangular. So equal angles. Alright, so if we have 3 equal sides, so we just make up a number. If we say that this is 10 centimeters, and this is 10 centimeters, and this is 10 centimeters. I'm just making up the distance. But now the angles have to be a certain number. So remember, we have to add up to 180. So if we did 180 divided by 3, we would get 60, 60, and 60. So all 3 angles the same, and they have to 60 plus 60 plus 60 is 180. So that's equilateral. Now on to isosceles. So isosceles triangles, if we look at them, you notice that we got 2 sides that are the same, but one side is different. And we got 2 angles that are the same, but the third angle is different. So in isosceles, we have 2 equal sides and 2 equal angles. Now the 2 equal angles are called the base angles. So you have 3 sides of the triangle. 2 of them are the same. The one that's not the same is what we call the base. Now the base can be on the bottom, but of course I could turn the triangle around and then not be on the bottom. So it's not always the bottom. And then these are your base angles. And they're going to be the same. Alright, so let's just pick a number here. So I'm going to say that this is 70 degrees, and that means that this one is 70 degrees. But remember, we have to equal 180, so 70 plus 70 is 140, which means I need 40 more here. And then I'm going to pick some numbers, so let's just say that this is 8 centimeters, and then this one is 8 centimeters, because they're going to be the same, and this one's going to be different. Now, you could pick any number. I mean, we could work it out, but for now, we're just going to stick with this. But it needs to be less than 8, because 40 is smaller than those 2. So let's just say that this one is 3 centimeters. And there we have it. So, equilateral, equal sides, equal angles. Isosceles, 2 equal sides, 2 equal angles. All right, so we're going to work with some isosceles problems first. All right, so what is the value of x? And that's kind of what we're going to be working with for most of these. Now I notice I've got one side. I've got these 2 sides are equal to each other, but this one is not equal to those. So 2 equal sides. That tells me that this is isosceles. All right, so that means that if these are my 2 equal ones, then this is my base. Okay. And if that's my base, then these are my base angles. So if this is 28, and this is 28. But of course this one cannot be 28 because I gotta equal 180. Alright, so what I'm gonna do is I'm gonna take 28 plus 28. And that gives me 56, and I'm gonna say 180 minus 56, and that's going to give me 124. So that means that this angle right here is 124 degrees. But I'm not done, because remember, we want to solve for x. So that means 5x plus 9 is equal to 124. So I got to do a little algebra here. So 5x plus 9 equals 124. I'm going to subtract a 9. I get 5x is equal to 115. I'm going to divide by that 5, and I get x is 23. All right, so now let's keep it going. Next one was the value of x. So again, I see these congruent marks, but I only have 2 of them. No third one, so that means that this is another isosceles. And that means that this is my base, so that means that these are my base angles. So that means that these are actually going to be equal to each other. I don't care at all about this third one up here. So I just need to set these equal to each other and solve them. So minus 4x plus 9 is equal to 8x minus 3. I like to take the small x to the big X, so I'm going to add 4x, add 4x. Now, since I'm bringing the 4x here, I need to move the 3 to the other side, so plus 3. 0, 12, 12x, and 0. So 12 is equal to 12x. I'll divide by that 12. So x is going to be 1. Okay. All right, so now this time, again, solving for x, but if I notice, I don't have any sides that I've been told that are equal, but I do have these angles that are equal, and I have 2 of them. So if I have 2 angles, then that means I have 2 sides that are the same. So again, this is another isosceles. And now I need to say, all right, well, here's my equal angle. So that means that this is my base, and that means that these 2 are equal to each other. So I don't care about this. I just care about these 2. So these 2 have to be equal to each other. So 8x minus 1 is equal to 4x plus 5. Small to the big. So we have 4x. That makes 0 is equal to, that makes 0, 6. And then I'm going to divide by.
Ms. Malloy, if you're in the building, please call Ms. Rutledge at 63001. Ms. Malloy, if you're in the building, please call Ms. Rutledge at 63001.
So 6 over 4, that reduced is 3 over 2, or you can write it as 1.5. Okay. Now we do have a follow-up here. It wants to know what is the length of all 3 sides of the triangle. So I'm just going to take this value. I'm going to substitute it in. So I'm going to use the 1.5 though. So I'm going to start with this one up here. So we have 8. It used to be x, but now it's going to be 1.5 minus 1. And then we have 4. It used to be times x. Now it's going to be 1.5 plus 5. And then we have 2 times 1.5 plus 11.
Ms. Tiffany Paulin Banks, if you're in the building, please call Ms. Rutledge at 63001. Ms. Paulin Banks, please call Ms. Rutledge at 63001.
Sorry for the interruptions, guys. So I'm just going to do 8 times 1.5 minus 1. That gives me 11. And then 4 times 1.5 plus 5 gives me 11, which makes sense because 11 and 11 isosceles, they should be the same. Then we have one more. So 2 times 1.5. Now this one should not be 11. 14. So that's the length of all 3 sides. You could be asked another question if you ever get asked about the perimeter. Then just add those up. So 11 plus 11 is 22. Plus 14 is 36. If you were asked that. Just keep that in mind. All right, one more on this side. What is the length of all 3 sides of the triangle? So,
Ms. Singletary, if you're in the building, please call Ms. Rutledge at 63001. Ms. Singletary, please call Ms. Rutledge at 63001, please.
Again, sorry for the interruption. So I don't see any sides that have been marked, but I do see two angles. So I know that these two angles, so that means that this is the base, and that means that these are the equal sides. So we know that this is going to be an isosceles. And I know that these two are going to be equal to each other. So we've got x plus 20 is equal to 8x over 3. All right. So first I'm going to start on this side because I got a division here, 8x divided by 3. So the opposite of division is to multiply. So I got to multiply over here, but I need to be careful that I distribute, multiplying by both things. So 3 times x is 3x. 3 times 20 is 60, is equal to, that cancels, 8x. All right, I'm going to move the 3x over. So 60 is equal to 5x. I'm going to divide by 5. So x is equal to 12. Okay, so x is 12. But that's not the final answer because we wanted to know all three sides. So I'm going to take that 12, I'm going to substitute in. So here we go. I'm going to take my time and set up. So we're going to have 6 times 12 minus 12. That's going to give us this one. Then we're going to have just 12 plus 20 is equal to that one. And then we're going to have 8 times 12 over 3. All right, save myself some time. I'm just going to get the calculator out. So 6 times 12 minus 12, 60. 12 plus 20, 32. So right now we know that this one is 60. We know that this one is 32. Well, isosceles, this one should be 32. So let's check it. So 8 times 12 divided by 3 gives me 32. And again, if you ever got asked about the perimeter, you could quickly add these up. So 60 plus 32 is 124. But this is what you were asked to find right here. All right. Okay, let's head to the back. Okay, so use the figure shown, find a measure of angle RSQ. So I'm looking RSQ, so that is this angle right here. And then what is PR? So PR is that whole thing. All right, so I'll come back to that later. So we'll focus on this one first. So I see two triangles here, but I also see a big triangle, PRS. And I notice that PRS, these two sides are the same, which means that this is a isosceles triangle. So triangle PRS is isosceles. So this side and this side are the same, which means that this and this are the same. So that means that this is 31 degrees and this angle is 31 degrees. Okay. Well, if that's 31 and 31, then this whole angle here, so talking about this whole angle, those three have to make 180. So I can add these up, 31 plus 31, that is 62. 180 subtract 62 is 118. So this whole angle is 118 degrees, but not this half. So remember, we're looking for RSQ. So this is going to be half of 118. So I'll take 118 and divide it by 2. I'm going to get 59. So this angle right here is 59 degrees. Which means the one right next to it is also 59 degrees. So the answer here is 59. Now, the next part is PR. So PR is all the way across. Now, it's easy to say that this is 4 and this is 4. And that actually is correct, but this is y. So remember now, you got a triangle here, PQS, so just this half over here. That has to make 180. So 31 plus 59 is 90, which means that this right here is actually a right angle. So this is 90, which means this one over here is 90. So 31, 90, 59, 31, 90, 59, they're the same. And so this is 4, this is going to be 4. So PR is all the way across, so that's going to be 8. So it takes a little bit of time, but I don't think too bad. All right, we got a few more to do. So come down. So just a reminder, because we're going to get some equilaterals in here. Equilateral triangle is equiangular, so equal angles. And then also going to be equilateral, so equal sides. So equal sides, equal angles. All right, so we're going to solve these problems. Now remember, for this, that all these angles are going to be 60. Because equal angle, 60, 60, 60 adds to 180. All right, so let's solve. So if the measure of angle CBD, so this angle here is 130, so we're talking about this part here, this is 130. What is BAD? So we're looking for this one. All right, so we got two triangles. Let's talk about what we notice. So ABC, this triangle, well, 1, 2, 3, 3 equal sides. So triangle ABC is equilateral. Now that's equilateral. That means that this is 60. That means this is 60, and that is 60. Okay. Then I got this other triangle, ABD. Only these two sides are the same. That side's not the same. So that means that triangle ABD, if we got two equal sides, that's going to be isosceles. Okay. That's going to help me right here. So don't forget, up here we were told that CBD is 130. So this is 130. Well, this one's 60. They have to add to 130, so this is 70. And I look on, so I'm in this triangle. And I'm looking and I'm saying, oh, well, these two sides are the same. So that means that this angle is equal to that angle. So that means that this is my base up here for my isosceles. So that means that these two are going to be the same, and they got to add to 70 to make 180. So I'm just going to say 180 minus 70. Now that's 110. Well, that's not 110. It's going to be half of 110, which is 55. So this angle is 55, and this angle is 55. So what's the measure of angle BAD? (55 degrees). All right, it's a fun one. All right, continuing on. Angle U. So let's look. We've got two triangles again. 72's in this triangle, so I'm going to only focus on this triangle. Now, I do have three sides that are marked, but only these two are the same. So these two are the same, so it tells me that TSV is an isosceles. Okay. So that means that this angle and this angle are the same. Now, again, you're like, why am I doing this? I'm trying to get U. Well, we got to work our way over. So I'm going to say 180 minus 72, that is 108. Well, that angle's not 108. These two together add to 108, so I got to divide that by 2, and I get 54. So this angle is 54, and this angle is 54. Oh, now you got to remember back to a previous unit. Right here, we have a linear pair. Side-by-side angles have to make 180. So these have to get me to 180. So this is 54. 180 minus 54, that is 126. Okay, and now we're into the next triangle. Now let's focus on this triangle. Well, this two marks, those two are the same, and then that. So that means this one's also isosceles, TVU. So triangle TVU is isosceles. So that means that this angle is the same as this angle. So I just got to do 180 minus 126, which I already know is going to be 54. But that angle's not 54. It's going to be half of 54. So it's 27. So this angle is 27, and this angle is 27. So the measure of angle U is equal to 27 degrees. All right, we just got a couple left. So if you want to pause it, take some time to try to work these out. You can't. So measure of PNO, that is this angle, and NOP, that's that angle. So really I just need to find all the angles. So if I notice first, MNP, so forget about everything over here. MNP, that triangle, 3 marks, 1, 2, 3, all 3 are the same, so that's equilateral. So triangle MNP is equilateral. So that means that this has got to be 60, this is 60, and this is 60. Well, let's get us somewhere, because here we know that these two, linear pair, so these two have to make 180, so that's 60, then this has to be 120. And now that gets me over here. So NOP, this triangle, 2 sides are the same, 3rd side is not. So that means this is isosceles. So triangle NOP is isosceles. So that's 120. So these two have to help me get to 180. So 180 minus 120, which is 60, and then divided by 2 gives me 30. So this is 30, and then this is 30. So PNO, that was 120. And then NOP, that was 30. So we had no numbers to start with, and we ended up finding them all. All right, one more little test question here. Which of the following statements is incorrect? Incorrect. All right, so here we go. Let's notice what we know. See what we know about triangle. We got 2 equal angles. So 2 equal angles tells me isosceles. So that means that this side and this side is the same, and this is my base. Because remember, the base has the 2 equal angles. So that tells me that this is equal to this. So these are the same. So this is going to be 40. But I come over here and I see x is 8. So maybe I need to solve for this. So I can say 8x minus 24 is equal to 40. Add the 24. So x is 8. Okay, so x is 8. Since I know x is 8, I could come right here and I could say, oh, well, let's figure out what this is. So we can say 6 times 8 plus 10. 6 times 8 is 48 plus 10. It's 58. So this is 58, that's 40, and that's 40. All right, let's come over here and see what we have. FE is 58. FE, 58, yes, that is correct. But remember, we want to know which one is incorrect. DE is 58. DE is 40. So that's the one right there. X is 8. Yep, we've already proven that. And then DF is 40. Yes, we already know that. All right. Good luck.